is one of the top people from our pellets industry. He's a consultant, Mr. Saralaya. His name is Mr. D. L. Saralaya. So I would really welcome if our friends from America, they continue to be with us, and we will be very, very delighted, in fact, and we will be very grateful that I know United States is one country, my daughter is in Denver also, that they don't like to talk after office hours about business. But Indians are different, and I am sure you will agree. So with these words, I will request our next speaker is an outstanding mechanical engineer called Mr. D. L. Saralaya. And Rishabh, I hope you can put Mr. Saralaya online so that he can, come. He's there. I'll just say a few words because he is one of our oldest friends of Pellet Manufacturers Association. Very few people know that he has spent the entire lifetime with pellets. He joined his career. He's a mechanical engineer and also a master's degree from Indian Institute of Science, Bangalore, which is the top institute for metallurgy in those days. Mr. Saralaya joined the famous company, still there, Kudarmukh Iron Ore Company Limited. It is the only public sector undertaking in the pellets industry. And he's an entrepreneur. He's heading a company called Techno Engineering, and he is also a consultant for new pellet plants coming up in India. I saw a question by somebody that what are the new pellet plants coming in India? I'll request Mr. Saralaya to say, I can't answer it right now. I think Saralaya sir will be able to answer. Over to you, Mr. D. L. Saralaya.
Thank you.
Yeah.
Good afternoon. Yeah. Can you share the screen?
Yeah, he's there.
Are you able to see the screen?
Yes. Go ahead.
Okay, thank you. So I will be talking regarding the challenges faced by the Indian pellet manufacturers. Okay. So the target is to produce 300 million tons of steel by 2030. Accordingly, iron bearing material requires at least a minimum of 450 million tons. Balance can be made up by scrap and other materials. But all this will be pellet, sinter, and good quality ore. So good quality ore is not available now much. That's why the blast furnace people totally depend on pellet and sinter. So Indian blast furnaces, they are not using much of pellets now, maybe around 20%, 30%. They can use up to 50% pellets with the existing blast furnace. More than that, if the pellets have to be used, they have to modify the blast furnace design. So what I feel is we should be able to produce 300 million tons of pellets maybe by 2030. Why pellets? Why not sinter? Because sinter is more detrimental to the environment, whereas pellets are much better when we consider the environmental impact. So other thing is, so far all the big pellet plants, all we import the machinery, import the technology, either from Metso or from Autotech or from Uralmash. But I think we should develop in India itself the Make in India concept. We should have the pellet plants which are made totally in India. And the new pellet plants what are coming up now, as of now, maybe one is coming up in Hospet, that is jointly by Fomento and BKG group, that is 3.2 million tons. Other pellet plants planned are by Tata Steel. They are planning one more pellet plant, maybe in Kalinganagar. Jindal Steel Limited, Jindal Saw, they are Jindal Steel, stainless steel. They are planning one pellet plant in Kalinganagar. Plus other plants like 1.2 million ton plants by Atta Group and 2.4 million tons pellet plant by MSPL, that is Baldota Group. So many other plants are coming up on the pipeline. one plant is coming up in Chennai by one pellet plant group in Chennai. Okay, there are many people trying to put up pellet plants. We don't know how many will come. But what are the challenges we are facing in making pellet as a good pellet? The first problem is the feed ore quality. The Indian feed ore is very, very difficult to make pellets because of that higher LOI. And comparatively, we have got a combination of soft ore and hard ore. The alumina by silica ratio in the states like Orissa is not very favorable for making pellets. And inconsistency in ore quality, because you see you don't get the same quality of ore every day. So most of the plants, if you see, every hour the feed quality is changing because of one is the hand-to-mouth supply of iron ore, because there is no time to mix and make proper feed mix. Other one is the iron ore quality itself, what is supplied by different mines. So what is the solution? Solution for this will be to have beneficiation plants and make a consistent quality ore. And other problem what we face is we don't involve the R&D people in the day-to-day operating the plant practices. All our operating and maintenance practices are individual to the particular plant. JSW or JSPL or SR or ArcelorMittal, all are having their own practices, which is sometimes it works well, sometimes we have a lot of problems with that. So what we should try to target is we should have a common practice where, like JSPL Barbil, they have developed one very good system. So see, everybody should follow that system, which will be suitable for making good maintenance and operating practice. One thing is, okay, availability of ore. Okay, we have to live with sometimes with the whatever available ore, but then how to make good pellets even with that. That is where the operating and maintenance practices come into picture. So if you see the different Karnataka, Chhattisgarh, then Orissa and Jharkhand, all these ores, there is some difference, but mostly all are having very high alumina, more than 2.5%, 3% alumina. Sometimes it goes up to 4% also. So this alumina has to be reduced. And also the iron content in the ore is mostly now 55%, 56%. We have got a lot of LOI in the iron ore. So one possibility is going for reduction roasting, where we can get a better quality product, in whether LOI or alumina, everything can be reduced by going for this. I think IIMT Bhubaneswar has worked on this. I think Dr. Biswal will explain more on this, and he's the right person to tell how to go about this. And all our plants, if you see, they are all merchant plants. Like most of the time, iron ore testing is not done, and nothing is based on the actual type of ore what we are having. Everybody is putting up the plant, maybe 1.2 million ton plant, you call it. Everything is similar. Like you take a 63 meter length, everybody is having the same furnace. So different ores. So then we face problems. So some operating practices, some procedures, everybody wants higher production. So most of the time we don't care about the quality of the pellets. But yeah, we have to see how to overcome all these problems. How can we improve the properties of the product? How the operating and maintenance people, they can have a good practice of operating and maintenance, so that even if there is pressure from the management, we should insist that this is all, we can make good pellets, only this much. More tonnage will really hamper the production. Not only that, it will hamper the equipment itself. I have seen pellet plants having bent pellet cars where they cannot run the next day. It is like that. So you have to be careful. You have to be careful when you are operating the plant. So we have to give more time when the LOI is more. The drying and preheating time has to be more. So your production has to come down if it is designed on a normal operating way. The pellets must be dried, cooked slowly in the preheating zone and the drying zone. So whenever you try to move the machine faster, what happens is this high LOI that creates problem and the pellets start breaking down and becoming fines. And if you don't take care, then everything will be bad. The pellet cars get blocked. Then you don't get the proper properties. You don't get the CCS and other properties will not be there. So we should take care. We should see that depending on the LOI, depending on the alumina content, we have to see what is the best operation, how to make good pellets even with the bad metal. That also we should learn. And other problem with our Indian iron ore is the grinding system. Okay. Normally in the soft ore, we try to grind, you generate a lot of microfines, that is minus 10 micron. At the same time, we will be having plus 150 micron metal, which is not desired for making pellets. So to have how to do a good beneficiation so that we control at least this minus 10 micron and plus 150 micron. This has to be controlled. For that, you have to have generate a proper beneficiation procedure. Maybe you have to use a combination of cyclones plus Derrick screen, where you reduce the generation of ultrafines. You get a good product, at least as far as you can maintain proper permeability, proper porosity in the pellets, so that your cooking will be all right. You will not have any higher FeO content in the pellet, which is detrimental for the process. And even in the grinding also, you have to maintain proper mill density with the combination of cyclone and screen. All this is one system what you have seen. The other problem is what you get the filter cake moisture when you filter this type of material, very high minus 10 micron. You cannot control the moisture, so it goes to 11%, sometimes 11.5%. So it becomes very difficult to make good pellets with this. And also what happens with this iron ore, sometimes you get a lot of floating material in that, low density silica material, alumina material, which can pass the mill. If you maintain slightly lower density in the mill, all this metal will pass and they go to the cyclone, they block the cyclone and they go to the overflow. Then they create problems in the thickener, create problems in the filter gets damaged. All these things we have to take care. The operating and maintenance people have to learn all this and take care of all this. And the filter selection also, whether you go for a pressure filter or for a membrane type of filter, or you go to a ceramic disc filter or a disc filter, you should be very careful even in selection of filters, selection of procedure. The one solution, what we can do, suppose you say we cannot control the moisture, slightly higher moisture if you have to get the material. The combination of dry and wet grinding, maybe a small dry grinding system with a better wet grinding system, that can solve the problem of at least balling. Otherwise, what happens? In the case of balling, you get plastic balls, the D-shaped balls, which will not be properly fired, which will have different uneven shapes, which will not also be having good looks and good properties. So the operating and maintenance people, they should have proper understanding of the process, the proper equipment and operating procedures. The furnace feed should be evenly distributed. You cannot have ups and downs in the furnace, because the furnace can do the work to a limited extent. So whatever goes to the furnace, 50% of the work has to be done before feeding it to the furnace. The care for the burner operating procedure, you cannot have a very high fuel at some point and no fuel at other areas. You have to take care of all the things. And you have to keep proper watch on the pressures of the hood, pressures in the wind boxes, because it also indicates whether you are operating properly or not. What happens if the pressure goes high? What happens if the pressure goes very low? All this system has to be studied. System has to be taken care of. So this is very critical for the operating and maintenance people. So these are some of the things which the operating maintenance people should take care: disc, bed and scraper, furnace seals, pellet car, grate bar, refractory, roller screen gap, drive and discharge alignment, lubrication system. All these things have to be taken care of. The other problem in most of the plants is the approach for the operating and maintenance people. There should be proper approach when we design the plant. This comes at the design stage itself. The designing of the plant, we should take care, the operators, the maintenance people are able to go to each and every area, check the area. If you don't do this, then people don't go to the areas, then they don't check, then there is a lot of spillage which you cannot control, and it creates problems, creates accidents. All these things should be taken care of.
Mr.
And
Saralaya, if you can
maintaining the
wind up.
data.
Yeah, because there's, if you can wind up and then we can.
Yeah.
Oh, you're already there. Good. Thank you, sir. Thank you. Thank
Yeah.
you very much.
Yeah.
Sorry to interrupt you, but thank you, Mr. Saralaya. He has a lifetime of experience, and I think those slides which you showed are extremely useful. Every state has different mineralogy,
Yes.
and I think you are the first speaker to tell about different states, the different this thing. And thank you very much.